So PFAS-free heat pump, I don't know how it is in English, but I could see that our international guests were falling asleep with all the German talking. But maybe that's also due to the fact that you arrived quite late. I don't know. Is it okay in English? Oder in Deutsch? Ella Podansk? English? Okay. Then English. So this PFAS-free heat pump, we don't have a PFAS-free heat pump. This is a project funded by some Swiss foundation, I think, which is located, or the project is located at this University of Applied Science of Eastern Switzerland. And I'm working a little bit on the side. And in the beginning, the focus was, as you mentioned, Andrea, just the refrigerant. And I said, no, this is not enough. The heat pump has a lot of other components which may have PFAS inside. And let's have a look. So the challenge is that the heat pumps, they should provide clean heating, especially when powered with renewable energy. But the F-gas refrigerant might be a problem because some of them, they degrade in the atmosphere to something which is not so nice. So this is the how it was in 2019 in Switzerland. You can see there that only a very small percentage. I mean, you can hardly see the green part of the circle with hydrocarbon, with propane. So the majority is 410A, and some with 134A. And of course, we had the CFC ozone layer problem, and then the global warming, and now we are talking about PFAS, and with the HFO refrigerants about trifluoridic acid, TFA. And also when the service technician is soldering on the system, then there might be some poisonous decomposition products. And these PFAS and also TFA, they are forever chemicals. So the TFA we find in the water will remain in the water for thousands of years. So what we do today is also valid for our grandchildren, grandchildren, and you can have many 100 times the grand before you reach a point where this will be gone again. The PFAS are found in many places, like the typical example is the frying pan, the Teflon coating of the frying pan, but also clothing is a big area, and then also in the refrigeration system, in the heat pump system, for example, the coating of some compressor parts to reduce the friction, or the O-rings whatsoever. When it comes to the refrigerant, we have gone from natural refrigerants to CFCs, then to HCFCs, and then to HFCs, and now to HFO. And with HFO, the one you have in your car air conditioning system, 1234YF, converts 100% to TFA in the atmosphere. And the big problem, I will show you a slide or a picture of that, the big problem or the big challenge is that this happens within 1 or 2 days. That's why the global warming potential is low, but that's also whatever is coming out of this 1234YF, trifluoridic acid, is very local. Yeah, so whatever we emit here will never reach Africa or Australia. It stays inside Germany. And here you can see how it's working. Yeah, we have the different emissions. And then this, the HFO decomposes to TFA. Also 134A does. But with 134A, it's 20% TFA, which you get. And the atmospheric lifetime of 134A is something like 8 years. So whatever you emit here in Germany will decompose to TFA in Australia or in Antarctica or somewhere, but not here in Germany. And then, of course, deposition happens either in the soil or in the water, and eventually in the oceans. In the oceans, we don't drink the ocean water untreated, so that's not the big challenge. But with the freshwater resources, it's a big challenge. Here are some measurements from Switzerland for HFOs. And you can see that the market introduction was somewhere around 2009, 2010, and how the concentration is going up. And the blue ones are for measurement close to Zurich, so a city in Switzerland. And they are outside the scale, so it's just cut off. And then the red ones are from Jungfraujoch, so that's somewhere on the mountains far away from civilization, and also there the concentration is increasing. And here you see a map of Switzerland with all the PFAS. This is not only TFA, this everything, all PFAS, like for example from firefighting foam or from the manufacturing of something, and how it is in Switzerland, where there is the highest concentration. And what we can see today with measurements of the lake water in Switzerland is that we do have already something like 0.25 to 0.91 microgram per liter TFA, and it cannot be removed. So when you take the drinking water, because in Zurich they take the water from Lake Zurich, in Luzern they take the one from Vierwaldstätter See, they get exactly the same TFA concentration. So in the end, if you look at beer, and there are measurements with beer, we also have TFA in beer. So the German purity law is no longer valid. We have water, hops, barley, and TFA in our beer. And then this is a map from Germany, and to the left you have the rivers, and to the right you have the groundwater, and also there is a rising TFA concentration. This is the Rhine River, because Karlsruhe is very close to the Rhine River. You can see how the TFA concentration is increasing, and very nicely you can see this where the Neckar from Stuttgart is joining the Rhine River. And one of the reasons why there's so much more TFA after the Neckar, because you have 800,000 cars in Stuttgart, and they all emit some HFO, some 1234yf, which degrades to TFA in the atmosphere and rains down locally. These are some measurements from the German Environmental Protection Agency from 8 different measurement points from the Deutsche Wetterdienst, and the conclusion is that we have 3 to 5 times higher TFA concentration today than what we had about 30 years ago. Now this one is interesting for everyone living in this area. This is a British simulation, and they said, okay, we assume that all 134A emissions we had in the year 2015 are replaced with 1234yf. So with 134A it's like 20% TFA, with the 1234 it's 100% TFA, with 1234 it's local, with 134A it's worldwide. And we will have the highest increase in TFA right here in Stuttgart, Munich, Vienna, up to 250 times more. Yeah, and then I had a discussion with Franz Quint this morning, our vice rector, and this would be a way of installing a water-to-water heat pump when you have when you clean the water. You take the water from the ground and then you clean it and then put it back in the ground, and maybe you get the permission to install a water-to-water heat pump when doing that. This is from China, and you can see that there are some PFAS measurements. And in the blood, you can do the same here. Christian, where are you? There. Yeah, you showed me your blood. Or you didn't show me your blood, but the laboratory evaluation. So what we have to do is somehow, get rid of this with the PFAS. And here you see a heat pump, and it's not only the refrigerant. It's the fan motor, it's the power electronics, compressor, expansion valve, electrical and electronic parts, evaporator coating. There are a lot of places where you have some PFAS in this heat pump. But they only make up a small percentage of the total weight, and the main fraction is in the refrigerant. And unfortunately, there are some publications, they state that in the environment, 60% of the PFAS is coming from refrigerants. In case you want to go home, like Edgar, you want to go home and look at your heat pump, these are some of the trade names of the different PFAS components. And of course, they can be found in the heat pump. You can also analyze the components. If your supplier doesn't tell you or doesn't want to tell you, then you can make a measurement and then find out if there's PFAS in an O-ring or wherever. And they have these 2 measurement methods at SPF in Switzerland. So this is something we are doing now with Heim, with their heat pumps, to find out how many components there are with PFAS in the heat pump. And as you can see here, this is an example for an outdoor heat pump, reversible, so it can also be used for cooling. 30 kilowatt heating capacity, 22.4 22 kilogram of refrigerant, and that's 98% of the PFAS, and the total part, the fraction inside the heat pump is only 2.8% of the weight, but it's there. And there's an example down there at the bottom where you can see like the compressor, and then you have the side glass in the compressor, and the O-ring of the side glass is the challenge, because this O-ring is made with a component containing PFAS. Now there's this ECHA thing, the German or not the German, it's Germany, the Netherlands, Denmark, Norway, and Sweden made a proposal to regulate the PFAS inside the European Union. And we are not alone. This is a suggestion from California, and California is always ahead when you look at the US, and they will also do something about PFAS. We already have seen this slide. It has a lot of impact on our body. Actually, the people are talking about that this TFA is influencing the fertility of the human beings, which might be good against overpopulation. So this is an example that it can be done. This is a company from the outdoor area, and they decided some years ago, 2010 or year or two before that, to get rid of PFAS in all their products. And the only thing which is left is their tents. Everything else is converted. There's no more PFAS in their products. And I'm sure that this is also possible to a large extent. There might be a few essential use things in a heat pump or in a refrigeration system which cannot be converted, but a lot of things can be converted. Because we also had heat pumps and we had refrigeration systems before PFAS were invented. We had, as you saw this morning, or earlier today, in the 1930s, heat pumps running without PFAS. So it's possible. In terms of the refrigerants, there was this investigation from NIST, where I started my career in 1986. And they say after HFO, there's no more chemistry, doesn't give you any more new molecules. You have to go back to the natural fluids. So we can use all the different ones. And let's go one back. In the 1920s, propane was marketed as the safety refrigerant because it's non-poisonous as compared to ammonia or other ones. This is the one I mentioned earlier today, how the refrigeration or the refrigerator industry converted in the early 1990s. And I'm quite sure, with also what Lena presented, you had 30 manufacturers, now it's 50. We will see something similar for heat pumps in the next couple of years. And unfortunately, also hydrocarbons have the highest efficiency. So that's very good. We change away from PFAS refrigerants to the natural fluids, and we get a higher efficiency. And also the CO2 emissions during the production of the refrigerant is much lower. You can see here that for 1234yf, it's about 11 times more than for propane. So it's all in favor of going back to where we started 100 years ago. And since I wrote this book, I don't give this to me. I have enough copies. So thank you very much for listening. And are there any questions? Irgendwelche Fragen?